So today's topic about photoelectric effect. It's a very simple phenomena. Photoelectric effect is the process of emitting the electrons from the metal surface when the electromagnetic radiations like X-ray, visible light falls on the metal surface. Here you can see on the diagram that incident light falls on the metal surface and instantly from the metal surface photoelectrons or electrons are ejected. This simple phenomena is called photoelectric effect. Okay, there is a experimental setup how scientists have done the experiment of photoelectric effect. So there is a evacuated tube. Evacuated tube means uh, there is a vacuum inside the chamber, inside the tube, and there is a metal surface, and this one is collector. So when the incident rays falls on the metal surface, instantly photoelectron ejected from the metal surface, and it will be collected by the collector, and collector and the metal surface are joined by a circuit where a variable battery is used, where we can change the voltage of this circuit. And there is another component used, which one is emitter we use to determine or measure the current passing through the circuit. Okay, now I have discussed about the how it will be happen. So if we when a positive voltage is applied, like if we apply 5 to plus 2 volt, so it helps to push the electrons towards the collector. Why? Because if there is a plus 2 volt, then we can say that in the collector positive charge is accumulated. So if the positive charge is accumulated in the uh, collector, then positive charge will attract electron because electron is negatively charged. Okay, so as the positive voltage increases, so if we increase positive voltage, let's say 5 volt, okay, the more electrons will be collected because more charges, positive charges are generated in the collector, so more electron will attract towards the collector. Okay, and if the more electrons collected in the collector, then what will happen? The more electron will flow through the circuit, and if the electron more electron is flowing through the circuit, then we can say that more photocurrent will be generated. Okay, after a certain time, what will happen? After a certain time, let's say uh, this one, like this point, this one is 7 volt. After a certain time, like 7 volt positive voltage when we apply, then what will happen? The charges, positive charges are more positive charges are accumulated in the collector, but there is no more electrons to be collected because the electrons, they have gone to this circuit. There is no photo electrons produced by this incident rays, so there is no electron, that's why there is no current to be increased. Why? And at the 7 volt, we can say that it's the curve gain the saturation. Saturation means there is the electrons which collected by the collector, it will again and again flow through the circuit, so there is a constant current means there is a saturation of current, there is no change in current. So if we apply positive 7 volt, then current will be saturated. Actually, I have used an example that we have applied 7 volt, it could be 2 volt or 3 volt. Okay, now second thing, what scientists have done, that they they reversed the polarity, like this one is minus and this one is plus. and then they have applied voltage like minus 2 volt, like this one is minus 2 volt, minus 2 volt. Okay, then what they have seen, if we apply a negative voltage, so we have applied minus 2 volt, it pushes electrons away. It push these electrons are coming towards the collector. But when we apply negative voltage, then the minus negative charges will be accumulated here. Then what will happen? This one is negative, this one is negative. Then the collector will push the electrons away and makes it harder for them to reach the collector. Only so there are electrons which have kinetic energy maximum. Okay, so those electrons which have kinetic energy maximum, like most energetic electrons, can only reach to the collector. Okay, now if we apply or increase, let's say negative voltage, let's say minus 3 volt, then some electrons will not be reached towards the collector. Okay, now if we apply a certain voltage, like a voltage whether negative, like let's say 5 volt, sorry 7 volt, minus 7 volt. Okay, when the negative voltage is strong enough to stop the most energetic electron before reaching the collector, current becomes zero. Why? Because if we apply like 7 volt, minus 7 volt, and there is a more negative charges for this, if the electron which have most kinetic energy, maximum kinetic energy, if they don't reach to the collector, but just before the collector they repel back, then the potential for which the kinetic energy which have the maximum kinetic energy of electrons will be repelled back towards the from the collector. Okay, so there is no current flowing through this circuit because the electron have maximum kinetic energy also does not reach the collector. So if there is no electron flowing through the circuit, then current will be zero. There is no current. So here you can see on the graph that we are increasing negative voltage minus 2 volt, minus 3 volt, at a point minus 7 volt. Okay, for which there is no current. Current is zero. So the potential at which the maximum kinetic energy of an electron does not reach the collector and it just to reach the collector, before that it repel back, that potential is called stopping potential. That means what is stopping potential? It have stopped the electrons which have maximum kinetic energy also. So the voltage is called stopping potential. I have we denote this voltage is V naught. Okay. At this point, the maximum kinetic energy of electrons is equal to maximum kinetic energy. The electrons which have maximum kinetic energy is equal to the work done by the stopping potential. So for V naught, the potential have done the work to stop the electrons which have maximum kinetic energy and also which have less kinetic energy. Okay, so work done by the stopping potential is E into V naught. Okay, it will be equal to the kinetic energy maximum. Those electrons which have maximum kinetic energy, it will be equal to the E into V naught equal to maximum kinetic energy of the electron. This one equation is very important. Okay, now that's the experimental graph. Okay, so here you can see that if we does not change the frequency of incident rays, like there is a frequency of nu, but we are not changing the frequency of incident rays, but we are changing the intensity. Intensity means brighter the light. Okay, so here I3 is greater than I2 greater than I1. So if the intensity of light increasing without changing the frequency, then we are seeing that um, current increases for different intensity of light without changing frequency. But if we does not change the frequency and we are changing only the intensity, but we can see that the stopping potential for different intensity of light is same, that is minus v naught. But according to the classical theory, what will be happen if the intensity is increases? So the kinetic energy of electron should be increased. Okay, because intensity has increased. According to the classical theory, I am saying that. So the kinetic energy, the electron which have maximum kinetic energy, it should be increased. Okay, it should be increased, but if it is increased, then what will happen? E is the charge of an electron, so stopping potential should be increased. Like for I1 it is like this in the point, for I2 it should be like this point, for I3 it should be in this point. So for different intensities the stopping potential should be increased, but according to the experimental graph, here we can see that the stopping potential is not increased. Why? So, according to the classical theory, and classical theory does not explain that why it's happened. Okay, so there are some experimental observation uh, about photoelectric effect. It's a instantaneous process. There is no time gap between the incident rays falls on the metal surface and electrons are ejected. There is no time gap. Okay, another one is at a particular frequency maximum kinetic energy of electron is independent of intensity of incident radiation. Okay, and another one is above a particular frequency, photoelectric effect happens. Now, these are the experimental observations. But according to the classical theory, light is just a wave. Light falls on the metal surface. This one. So the wave should continuously give energy to the electrons. After some time, the electron should collect enough energy and then get emitted. Okay, like when will the wave will continuously give? There is a electrons are here. The wave is coming, wave is this one is like a, this one is wave is coming and continuously it will give the energy to the electron. If when the electron will get that much of energy that it can be ejected from the metal surface, then it will be ejected. So there should be a time delay now. So because it will, when it will get energy, then it will be ejected. So it should not be instantaneous process according to the classical theory. Uh, and another one is according to the classical theories, any frequency of light should work as long as it shines long enough, like any frequency of light. So if the frequency is new, it should be like, because wave is coming and giving the energy to the electrons, so any frequency of light should be work to obtain a photoelectric effect, like electron should be ejected for any frequency of light. But according to the uh, experimental observation, it's shown that above a particular frequency, photoelectric effect happens. Like there is a certain frequency below which frequency the photoelectric effect does not happen. Above that frequency, it will be happen. Like this, there is a frequency nu naught below which frequency, if the frequency of the incident rays is less than or greater than this frequency, that frequency is called threshold frequency or cutoff frequency. Above the frequency nu naught, the photoelectric effect will be happen. Below that frequency, it will not be happen. So these two things are not observed by this experimental observation. Another one is brighter light should make electrons come faster. Why? So if we apply, I have discussed earlier, brighter light mean intensity of incident rays is changing without changing the frequency. Frequency is new. So if the brighter light is falls on the in a metal surface, so kinetic energy of electron, maximum kinetic energy of electron should be increased, and hence the potential stopping potential should be increased. But according to the classical, experimental observation, the stopping potential for different intensities without changing the frequency of light is not changed, it is same. So if v naught is same, then maximum kinetic energy is also same. So this one is also this one, that at a particular frequency maximum kinetic energy of electron is independent of intensity of incident radiation. We have seen that if intensity is changing but the stopping potential is does not change, so the maximum kinetic energy of electron will not be changed when intensity of light is changing. So it is independent of intensity of radiation. Okay. So there should be another one is there should be a time delay before emission, because wave will come and it will uh, give the energy when the electron will get that energy, that it can be ejected from the metal surface, then it will be ejected. So it should be a there should be a time delay, but there is no time delay, so it's an instantaneous process. So here classical theory fails to explain the photoelectric effect. Now comes Einstein, the famous scientist. We have heard about it now. The scientist who have got a Nobel Prize uh, at I think 1925 for discovering this one another famous equation about photoelectric effect. So by this using the that equation, the photoelectric effect was explained. It was not explained by the classical theory. Here, classical theory fails in the to describe the phenomena of photoelectric effect. So now comes Einstein. What did Einstein told? Tell. Okay. So Einstein's according to the Einstein, the Einstein's photoelectric equation is h nu equal to 5 plus kinetic energy maximum. Like I'll discuss that equation later. And so according to the Einstein, light consists of tiny packets of energy known as photons or light quanta. Like what he have told, he told that so light is not a wave, like it the energy is not transferred through waves. It's a packets of energy, it's not a continuous manner. Energy is not going flowing through like a continuous manner, it's a discrete, like a packets, one packet, two packets, three, but they are flowing like a packets of energy. So one packet, this one packet is called photon. This called photon. Okay. And each packet carries energy in h nu. So one photon, this one photons of energy is h into nu. Nu is the frequency of incident radiation, and h is the universal constant, which is Planck's constant, and the value of h is 6.022 into 10 to the power minus 34 joule second. Okay. The proportionality constant h has become known the Planck's constant. Okay, and here is the phi. Phi is the minimum energy required to remove an electron from the surface of the material. So phi equal to is h into nu naught. I have discussed earlier that what is nu naught. Nu naught, nu naught is that frequency above, below that frequency, if the incident radiation of light has frequency nu and it is less than the threshold frequency which is nu naught, then photoelectric effect does not happen. What it means electron will not ejected from the metal surface. If it is greater than the threshold frequency, then it will be eject from the metal surface. Electrons will be ejected. So H into nu naught is called phi, like work function of the material. So phi is that at minimum energy required to remove an electron from the metal surface. So this energy have to be given to the electron to eject from the metal surface. So if the photon has, so this one equation I will explain now. So h nu is the energy of one photon. So it will be divided into two parts. One is work function of the material with that phi is that energy required to remove an electron from the metal surface, and after that the the electron, which will be the excess energy of electron, will use in the kinetic energy of electron. Okay, so phi plus kinetic energy maxima. So what will happen, that energy of one photon is h into nu. Okay, here you can see on the diagram that the so incident lights are coming, like we have well, according to the Einstein, that it's a tiny packets of energy. So this one is one packet, this one is another packet, this one is another packet. So, okay, so this one packet is called photon, which have energy h nu. So h nu of energy, so one photon will incident only in one electron. Okay, so it will interact with electron. So it will transfer, the one photon will transfer the energy which is h nu. If he got the sufficient, if we got the sufficient energy of electron, like electron have got the sufficient energy h nu, then that then it will be ejected from the metal surface and it is ejected. If he didn't got that much of energy which will be required to eject from the metal surface, which is phi, and that minimum energy, then it will not be ejected from the metal surface. Okay, so those electron, after incident the photons on the metal, photons on the electrons, so different photons will be incident on different electrons. So one photon will be interact with only one electron. Sorry, one photon will interact with only one electron. So like three or four photon will not be interact with only one electron. It will one electron and one photon. Okay. So after so from this we have explained one experimental observation, that photon will be incident on the electron. If the electron got the energy that it can be ejected, then it will be ejected. So it is an instantaneous process. One photon will get that energy, will give the energy to the electron, and it will be ejected or it will not be ejected. So it is instantaneous process. There is no time delay. One exertion that okay, one assumption is explained. Another one assumption is that